Okay, so I'm going to do a flight plan demonstration for planning a mission in the shingle point area with ebee. So I will be explaining using the ebee Classic and not the ebee RTK. So this is the original panel at the opening of eMotion. We have two drones already selected, so we have to make sure that we have at least the ebee selected here, and here we have to select the cameras. So we have to be sure that we have the cameras which we are using as a payload, which in this case is the Soda. You can also add the Sequoia if you'd like. So next step is to create mission. So we'll just write here, for instance, shingle point test, and we do a create mission. So I have already zoomed in into the working area. So let's zoom into shingle point, and we want to make sure that we have the best possible background image and data for our flights. I have been exploring what is in the background. You can have a look here, and for instance, if you choose Sensefly satellite or any other satellite image, what happens is that in fact, I think it's going to upload, when you zoom in, the winter scene, which is probably the highest resolution scene. It gives you an idea on the location, but in fact the details are not so good. So it's not really a very high resolution scene of the area. Let me just zoom in to see if it improves, but it really doesn't improve too much. But probably it's enough, especially once you are there, to better understand where you are, and this may be enough for the flight planning. But of course there are some buildings in the area, some houses at least, and you have to be really careful when planning for the flight. So let's keep either this one in the background or Sensefly satellite. Let's see, which one was it? Digital globe satellite, which is really low resolution. I will go back to the Sensefly satellite, and let's do a bit of the flight planning. To have an idea of the dimensions of the survey area, we have this measurement mode here. You can just click it, have a look here, and we can see that the area is 5 kilometers long. It was shown here, about 5 kilometers long. So it's quite broad area, and I would say that we would need at least 4 to 5 flights centered in a 1 kilometer wide area, but probably more flights to be done, since well, we'll have to check the time of each flight first, and also it will be important to check on the landing conditions, because they will really limit where we will be operating. So just make sure that remember that we are using the Sensefly ebee Classic and not the RTK Plus, which has much larger autonomy. In fact, I would like that you don't push too much on the flight time, so I would advise not to plan for more than 25, at most 30 minutes of flight time, and that you make sure that when the battery is at 30%, you will land the drone. So bring it back to the landing position and start the landing procedures. So just to be sure that you have everything well configured here in the eMotion, the first thing we'll have to connect to the drone. We will do the flight planning with a simulation. So here you select the drone which you will be using, which is the ebee, and we'll just click start simulation. Let me see what is the advanced. We don't need to use the advanced, I think. Yeah, so start simulation. Maybe we can just enable advanced functions, and then okay. It's not so important to have the advanced functions there selected. So now he is connecting to this virtual drone, the ebee Classic. If you have your own the drone setup, you can connect directly to the drone once it is connected. But for the flight planning, it is okay that you do it with the virtual drone. So I don't know why is it taking so long. Let's just wait a bit. Maybe it's because it's in the advanced mode. I will do a cancel, I will connect again, and I will take the enable advanced functions out. I don't know if it's a bug or what is it, but we really In fact, we don't need it. So start the simulation. Okay, and it has connected.
Pre-flight checks completed.
Whenever you have your drone with the battery on, it will locate the drone in the exact site where it is. So just be sure that the drone is pictured in the correct location, because it relates also to the accuracy of the GPS and if the GPS is working well or not in your drone. When you are doing the flight planning, it will just pop up in the last location where you were, and you will have to make sure that you are going to displace the drone to the location where you want to fly. So just let's, for instance, imagine that we are going to survey this area of the spit, and we want to place the drone here. We go into this sector, place start position of drone in the map, and we move it here. So we have the drone in the new position, but as you see,
pre-flight checks completed.
The flight area, it's not in the same location. This is the protection area, and we want to place these on top of the drone. So if we go here on this side, we can center working area on drone, and we have our working area on top of the drone. So this is quite important. The radius of the working area, currently it's 500 meters. We can just push it a bit to 700 meters because it will allow for a safety margin, and it will allow for a safety margin, and because sometimes when it's turning, it really needs a bit more of space. So here you have the wind direction and speed, which you should update according to your estimates or measures of the wind. If you are connected to the internet, it will go to a model and pick it automatically. This is the wind direction. So this would be northerly wind, this would be southerly wind, and this is important for the flight planning of the mission. Be aware that here you have the ceiling, which is the upper limit where you want to fly. Let's place the ceiling at 120 meters above takeoff, which is the legal limitation to what we have to fly in Canada without the SFOC to fly higher. And so we keep these at 120 meters. Be aware that if there is a shift in some conditions, this can block the operation, and you might need to change it and adapt it a little bit for a few meters just to tune it in. If you want to make sure that you have your background data in your computer's cache, since you will be flying without internet connection, just be sure that you download map data here. So it will download the Sensefly satellite map, and will also download the elevation data. So be sure to click here. This one may take a while, but it picks up, I think, what is in the window of operations here. If you want to have a look at the digital or at the elevation color map, you just click here and you have the background colors. It will not be an issue in this survey area because it's flat and it's at sea level. So elevation map, turn it on, turn it off, and you can tune in the elevation color ramp here. It will just stretch to the maximum and minimum of your working area. For instance, if you zoom in and you stretch, you see that it will stretch between -4 and 4 meters, and all the areas which are a bit higher will be in different color. So let's put it a bit wider. And here this is the transparency. So in fact it's the opacity. So if you want full opacity, you will see the digital elevation model. We want a bit of transparency to look what's underneath. We select 25%. So just let's go there, take out the elevation map. And then before starting to do the flight plan, I would like to emphasize on a few things which are important. So in this area, you see warning messages, which you may be able to acknowledge by clicking. So if you have a yellow warning, you can acknowledge it and it will just flash again white. This yellow warning is not really a very important, significant warning, but you have to be sure what it says. And here you have several virtual keys which you will hit depending on what you need to do. the, there are very important ones. One keys, which one, the most important ones for this area will be fast climb, because especially of bird attacks. So you want to be sure that you have fast climb in your screen and fast descent. This can be useful for avoiding bird attacks if they are if they are on site and you see the bird going very close to you. Just do fast climb, and if the bird continues attacking, in fact, you really need to do a landing, so you will hit go land. When you are landing, when the aircraft is approaching for the landing, it is very important that you keep your mouse over abort landing, especially when you are in rugged terrain, or in this area you may have holes, you may have a bit of water in the beach, or you may have even some tree trunks and branches which are normally along the coast. So you have to be sure that you are cleaning all the landing area for some tens of meters on the landing area. And when it is landing, it is good that the observer should be close to the landing site and should point you if you need to abort the landing or not. And then if he is landing, you can abort the landing just before he lands. Then you will fly up again, it will start hovering around your position, and you can really shift a bit manually the landing position into a better place. But of course this will be visually, and that's why you need a bit more of battery. So in order to be sure that you have these buttons here, you should go to options, and then you should go to user interface and be sure that you have show roll button, show fast climb button, and show fast descent button. So and then they will pop up in this area. I'm not sure if they are already by default here. Then local preferences, not very important. Features, log, folder. Let me see if there is anything else. Show all warning messages is important. Okay, so network, airspace traffic, these we don't need to press. User interface. Okay, so let's go to mission, and we will be planning our mission. So once this is the area where we are going to work, and now we want to select the best place for landing. So imagine that we are taking off from here. In fact, the resolution is not that bad. We can see the beach pretty well, and these white patches are lower areas which are frozen. So and this could even really give you a good idea on the area where you are. So first thing we'll do is click here, automatically set the start home based on the drone position. So we click here, and what it does, it will just put your start, your home waypoint on the location where the drone is. But imagine that you are standing in this site, you turned on your drone, and you want to land in a better place than this one. This is good for flight control, but it's not so good for landing. So you will want to be sure that you are landing in a good position. So what I normally do is I ask the observer, the ground safety personnel, to go and walk with the drone turned on and walk to a better location. Imagine that this is the best location. So once the drone is on, you will see the drone moving slowly to the new location, and then you will know where the drone will land. So if you see the position of the drone image here, what you will want to do is you will want to move this sector, which is the home waypoint, towards the top of the drone. So imagine the guy is walking with the drone, and you decide that the best landing spot is here. So you just want to do it like this. So in fact your drone is here, but your landing spot will be elsewhere, will be here, and you know this is clean area and better for landing. Okay, so this is really quite important to plan, to do a good planning for the landing. You also have to be aware that this is the start waypoint, and the start waypoint is it has at 75 meters above takeoff by default. You can change it, but you really don't need to change it, and it should be facing upwind. So you have to throw the drone against the wind, and this point should be located more or less in facing to the wind. So imagine we will be flying with northerly winds, So we'll have to throw the drone from here to there. So let's move this a bit further in this direction. So we know now that this is the start waypoint. Another important thing to do for the landing is to plan for the landing cone, which is the safety cone for landing. You can move it like this. And for instance, if you have no obstacles and you have a really flat area, you can land from any directions. All the directions are okay. So what you would do is do a full circle, and this means that when the drone ends the mission, you will hover around the home waypoint. You will decide you will measure wind direction, wind speed, and you will decide which is the best direction for landing. So this is good if you are working on the planes, but here in this setting, I would say this is really tricky, especially because we are working near the coast. And if you have a very small area to land, the drone, when it's going down, it goes down, for instance, from the north. In fact, if the wind is from the north, we would be landing from the south, and here it wouldn't be too bad that you would come and start descending along this direction, because there is a big area which is not water, and it will depend a bit on if these are lakes or not, or if they have water or not. But the problem is when you have surfaces with water, the measuring system with the distance measuring system is not working well, and so you should avoid flying over water when the landing approach is being done. So in this area, I would really emphasize on doing a cone along the beach. If the wind is from the north, and if we are landing here, then we could, but it's not really so good but to do it, because so what I would do is we would do one cone in this direction and another cone from this direction. So what we would need to do is to go to the cone, and let me see how it works. Landing parameters. Okay, we open parameters here, and then add another approach for linear landing. And we click here, and it creates another possible approach, and this means we have two directions from where the drone could land from. So, and I could do something like this, and this would be the best way to do it. But what would be the problem here? If the wind is strong from the north, then when the drone is landing, when it turns off, it might be shifted to this area. If there is water, it can land on water, so it can be a problem. So you have to take care of this. If the wind is from the south, then the risk is even higher, because it can be thrown into the water here. Remember that the drone, when landing, can disconnect itself and stall. Normally it does it from 2 meters above the ground, but if he is not measuring accurately the distance, he will stall from 10 meters above the ground, which means he will, if it's windy, he will be thrown away to a great distance. So you'll want to avoid that he will fall in the water. So be really careful when planning for the landing. Ideally, the landing site should be the furthest away from the ocean. Okay, if the wind is not strong, then it should be relatively okay it should be okay to use these two directions. But you really have to be sure about what is your planning for landing, so that it doesn't fall in the water. You may even want to do a first test related to this. So let's say the wind is not so strong and we are safe with these two cones. We can even add more landing approaches, but this could be a way to do it. So next step is planning for the mission. So for planning the mission, we go to this tab here. We will add a mission block, horizontal mapping here, and we will put the mission block more or less in the center of our study area. And so we have the mission block here. The mission block would be number 1. We check we have the solar camera. We are flying above elevation data. This is the ground resolution. In fact, what we should be looking here is we are limited with 120 meters of altitude, And I would suggest that we move this a bit lower, because if we put this altitude, for sure you may go a bit above it, and we are limited to the 120 meters, as I said before. So we'll do a better resolution. So for instance, if we change this to 2.4, let me see what happens. 100 meters above the ground, 2.5, 2.6. I'm going to push it a bit up. So this is 110 meters. I would say that we will be flying, we could fly at 106 meters, so 2.5 centimeters above the ground. And for instance, to cover this area that we have here, it will take 10 minutes to do it. So let's do a bit of a test here. So normally what we do is we would like to do the flying along the coast so that we avoid the time flying over the ocean. And we will move our flying area to pick this sector. Here, 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 here. We can add another point here just to follow up along the coast. Have a look at the flight time, and it's already in 30 minutes. So as I told you, I wouldn't like to do more than 30 minutes of flight time, and I would, now it is 29 minutes. Let's do it like this. And as you can see, we can even fly a significant area, but I would say we need, especially due to these irregularities of the speed, we would need at least 5 or 6 flights in the area. So this means that you only have 4 batteries, and you would like to continuously recharge the batteries for being able to fly the whole area in due time. So let me see. So we have the flight plan. We have lateral overlap of 80%, which is pretty good. I think it's quite enough for this area. If it's too windy, you can always choose the option, let me see, this option, crosswind mapping blocks. So if the wind is from the north, for instance, and it's, let's say, 6 meters per second, and you click here, you will just shift your flying paths according to the wind. This will assure that the speed will be more or less constant all over the flight, which is quite good, because it keeps the same spacing between photos. And this means it's a 25-minute flight. You even gain some time on it, so you might even want to add a type point here, a control, and then a waypoint, sorry, here, and then move a bit, and you gain this sector, which is good because afterwards you can do the next sector, which is a thinner area, so you could do it wider. So you can, in fact, you can fly. This would be 31 hectares, 26 minutes, which I think it's pretty. It is a pretty good flight, and I really wouldn't like to push this ebee, which has already, which is more limited than the others, more than this 25-30 minutes. So just be aware of the batteries and check if everything is going well. So next step, you would have to upload your data to the drone, and it's uploaded. You will have a look at the battery. If the battery is 100%, that's perfect. This is the flight time, home distance, link quality. It's very important that you have your modem slightly elevated. And then just be sure everything is going well. Have a look at the external storage in the camera to see if you have space in the SD card for the images. Yeah, and I think that's it. You can do some planning here with the flight plan, just to simulate the takeoff and the landing. And okay, so here we have an advisory. Longitudinal overlap might not be achievable. This is not, in fact, a big problem. It relates to this overlap of 80% and to the fact that due to the wind speed, it may not it may not allow to cover the whole, let me see, lateral, no, it's not lateral, it's longitudinal, so let's keep the lateral overlap in 80% so that we have more redundancy. And the longitudinal overlap, 70%. No, it doesn't bring in any message, so let's keep it in 70%. Yeah. So interlaced flight lines, I would not. I prefer not to use it because sometimes you save time. It went to 24 minutes, but there can be some issues related to changing light conditions. So just do normal. So if you look when it takes off in this flight plan, it goes first to this area and then it starts doing the survey. If you are interested that it first does this sector because it's the sector which is closer to you and you will want to be sure that is flying well under the ocean, you can just do reverse flight and you will shift the order of the flight path. But in fact, sometimes it's better that it flies first the areas further away from you and then in the end is closer to the landing site, because if there is a battery problem, you can land it quicker. So it doesn't have to do such a longer flight before landing. So let me see if I forgot anything. Be sure you clear your areas, your landing area. You can, if you want, you can change your landing site while on flight. If there is some kind of problem in the air, you can press Hold and you will stay in the same location waiting for your new orders. And you can even move during the flight, you can move the landing site by clicking here and moving it, and it automatically assumes the new landing position. If you for any reason lose the link connection, normally what you will see is link connection lost, a warning, and the drone position is just freezing. The drone has frozen in the last known position. What I would think you should do is try to look to see if you still see the drone. Normally what you would do, and you can see it here, you want to be sure that if ground modem is link is lost for 30 seconds, you will come back to the home waypoint and you will start landing after 3 minutes of flying on the home waypoint. If the link is lost, you will, in principle, you should come back. Sometimes what you could do, if you want to continue your flight, you see the drone hovering over you, but you have still no connection. There might be a bug or something in the software or in the computer. You can just take the modem out of the USB port, plug in the modem again, okay, and then afterwards you can just click connect back here, and you will connect to the drone, and you can even resume the mission after this reconnection to the drone, because it's not going to lose the mission itself. Okay, if you click here, this button is to show the footprints of the photos which you already did. So you may want to toggle it sometimes to check if you have already covered the area or not. And remember, when you are doing several flights, you want to be sure that these sectors are covered with an extra number of photos. So just do small overlaps between areas which are close together. What more? So I think this is the essential. Just keep the drone on site all times. Be in touch with your continuous in touch with your visual observer, with your ground support. Before taking off, I normally turn on the drone once, then turn it off by shaking 3 times, gently shaking the drone, just to see if everything is okay. Check if all the sensors are working well, if the Python probe is not clustered, has no problems. Also the ground distance sensor, if the cap is removed from the camera. Yeah, that's it. And just remember, when plugging and unplugging the camera from the drone, you should always have the battery off. So the drone should not be connected. So any cables that you are plugging in the drone, no battery. Also for downloading data, battery out of the drone off. If you want to take the images from the pictures from the SODA camera, you have two ways. Either you connect directly to the SODA, but I would prefer that you do it. It's better that you do it at the office, and you can also take the photos directly from the SD card to the computer. But there are ways to do the processing of the images and the project directly in Emotion, but that's another topic. Okay, so that's it. Save your flight plan, and you are good to go.